Hello everyone, this is Siddharth, and in this video we will be solving another question from the list that I have shared in the starting of this playlist. So if you don't know what we are doing, we are making a playlist on my YouTube channel where I will be solving all those questions which are related to each other, so that we can able to build pattern and able to solve the question in the contest as well as in the interview intuitively. So let's start solving this question as well, that is find kth smallest pair distance. So this is a very interesting problem, and it is hard level. The difficulty of this problem is hard level. So now let's try to solve this. So what we have to do, we have given an array and we have to find the kth smallest distance. So let me tell you. So we have given this array 1 comma 3 comma 1. Let me zoom it. Now what we have to do, we have to find k1. K is equals to 1, that is first smallest element, or the smallest distance, sorry. And distance, how they are representing distance, that will going to be the difference between two pairs. That is, if suppose there is pair a comma b, then the distance will going to be absolute difference, so b minus a. So now what we have to do, we have to calculate the kth distance in this given array. So suppose we have given this k1, so that will going to be the smallest one. So now let's first calculate the total possible distance in this given array. That will going to be 3 minus 1, that is 2, and then 1 minus 1 is equals to 0. Now we have to return the smallest one, so we can return 0. Now the brute force method for this question will be like, you can directly uh, you can you can directly find uh, total number of pairs difference and then sort it and then return the kth value. But that will be like too much time consuming, because for array which is of like 10,000 length, or 1 lakh length, then that solution will not work. So for this we have to optimize this. So, and you also know that currently we are on sliding window problem. In this series currently we are on sliding window. Before that I have already completed two pointer approach, so you can check it out, the previous videos of my playlist, and as well as this is the like third question of the sliding window, or sorry, second question of sliding window. So now let's start solving this question as well. So using sliding window, now what we can do, we can use binary search plus sliding window, so to solve this problem. So what we will do, we will like directly guess the distance between two pair, and that distance that we have just guessed, we are like assuming that the there are k element already present in that given array, k minus 1, which are smaller than that, or we can say more than k or as well. So that that distance will be satisfying the condition. So in this given array we have like, we will assume that is as mid value, that will going to be low plus high divided by 2. So now after like guessing this distance, now what we have to do, now we will start counting the number of pairs which are less than this mid value. If we are able to get the number of pairs less than k, like the count with that just we have done, if that is less than k, then uh, what it means that there are more, we have just counted less number, so we have to increase the, or we can say decrease the low value. So for that, what we can do, we can like do the same thing that we have done in the binary search. Low is equals to mid plus 1, or low is equals to, or sorry, high is equals to mid. So what it ensures that we can able to like cut this array into half and half and half, and then eventually we will reach to that element, or eventually we will reach to that distance, which is the kth smallest distance. That's what we have to return. Okay, so first what we have to do, we have to sort the array. So arrays dot sort, and then we can pass our array, and then after sorting this we can define two variable that will going to be minimum distance, and then it will going to be 0. and then maximum distance. Okay, and it will going to be the nums of nums dot length, or we can say like we can define it in the start so that we don't have to calculate it again, and it will going to be int n is equals to nums dot length. So this will calculate the length of the given array. Now we can pass n here instead of this, n minus 1, and then minus nums of 0. So this will calculate the maximum distance possible in this given array. And now we just have to do the same thing in the binaries as we have done. So while this minimum distance, let's copy paste this. So while this minimum distance is less than the maximum distance, so if this is the case, then what we have to do first we have to calculate the middle distance. So this will going to be middle distance. It will be equals to this minimum distance. Let's copy this, and then we can add the maximum distance minus the minimum distance. Why we are doing this? This is the standard process to calculate middle value so that the answer will not exceed the integer limit, and then we can divide it by 2. Now after doing this, what we have to do, we have to start counting the number of pairs in this given array which is less than this middle distance, so that we can able to find our k value. So for that we can use in for loop, and first we have to define two pointer as well, so that we can implement a sliding window approach. So left will be pointing to 0, and then count will be the answer that we have to calculate the total number of pairs. So or we can say total pairs, and it will going to be 0. So now what we can do, we can use in for loop for int right is equal to 0, and this right is less than n, and then right plus plus. So after doing this we have to increment and decrement our window. For that we can say while this nums of right minus nums of left, if that is greater than mid, then we have to decrement our boundary, because we have calculated this difference which is greater than mid, but we want less than mid. So for that we can increase the boundary so that we can decrease the difference. So left plus plus, and then we can increment our count value. So count is equals to, then we have to add the value of right minus left. So this will count in the current window, it will able to count the total number of pairs whose difference is less than mid, and we are incrementing this count value. But now what we have to check, if this count value we have just calculated, if it is less than k, if this count value that we have just calculated, if it is greater than k, so what it suggests that there are more element present whose difference is greater than k, greater than this middle distance. So now what we have to do, we have to find the k element. So for that we have to do increment, or we can say redefine a low value to mid plus 1, and in the else part we have to define our high value to mid. Okay, now after doing this, in the last we just have to return the low value, as this low and high will converging to that element, that distance, which is the kth smallest distance of the pair from this given array. And now we can try to submit this and check whether total pairs, we have defined this, so let's define it as count instead of pair. Now we can try to run. So there's an issue. While nums of right and then nums of left is greater than mid, So this should be mid distance. Now we can try to run this. So there is another issue. Oh sorry, this should not be low, it should be minimum distance. So minimum distance is equals to mid plus 1 and high will going to be maximum distance. So let's update it as well. Maximum distance. Now we can try to run this. Mid sorry, this should also be mid distance. Sorry for this. Distance. Okay, now we can try to, and this low value will going to be minimum distance. So let's update it as well. Minimum distance. Okay, now we can try to run this. Okay, so there is an issue for one test case. Issue is here I have done it by mistake. So this count value, if the number of pair is less than the k value, then what it suggests that we have to move our low pointer to the minimum distance. We have to increase it by the mid distance plus 1 so that we can able to find more number of pairs. And here it is fine. And then now we can try to run this. So there is another issue. Let me see. So this will going to be not plus. Plus is equals to, we have done it by mistake. So all the test cases have been processed. Now we can submit it as well. Okay, so we have successfully solved this question. See you in the next video. Bye.